Welcome. In this session, we'll learn what's Simulink and how to use it. So the goal of this session is to learn how to use Simulink in Matlab. Now, before I proceed with how to use Simulink, let me tell you something about Simulink. Now, first of all, why is MATLAB so powerful or very important programming language, and what sets it apart from other programming language is actually Simulink. And what is actually Simulink is actually it is a graphical tool to analyze or build systems or models in MATLAB. So it's a graphical tool to build systems or models in MATLAB, and we can perform the graphical analysis of those models and analysis in this MATLAB. Now, what is it actually? Instead of typing the code that we do in MATLAB, or you can say in R programming language, or C programming language, or Python programming language, what we have blocks. Instead of the code, what we have blocks available similarly, and we connect these blocks together. So we connect these blocks together to build any system or any model that we want to analyze in this MATLAB. So instead of typing this code, what we have blocks that we interconnect together and do the analysis that we want to perform. This is what sets MATLAB actually apart from other programming languages. This graphical tool that's referred as Simulink. So let me show you how to open this Simulink in MATLAB. Let's get started with that. Let's see how to open this Simulink in MATLAB. Now let's open MATLAB. This is MATLAB. Now, how to open Simulink in MATLAB is simply click on this Simulink tab, or you can type Simulink in command window. And once you type it, a window will pop up that looks something like this. Now, let me share the screen with you. A screen will pop up, or a window will pop up that looks something like this. Now, this is the window that opens after you click on the Simulink or type the Simulink. Now, after you open this, what you can do, you can click on this. This is called the library browser or simply Simulink browser. You can click on this, a window appears, another window appears that looks something like this. This is referred as Simulink library. And these are the toolboxes that are available in MATLAB. Depending upon the version of the MATLAB that you are using currently, there will be different toolboxes available to you. You can see there is communication toolbox, there is DSP toolbox, there is control system toolbox, there are several toolboxes, there are power system toolbox, and several other toolboxes that are available in this MATLAB, depending upon the version actually you are using. Now, how do we build a model in MATLAB? What you can do, suppose I want to, for illustration, let me suppose I want to display a sine wave. I want to display a sine wave. Now, to display a sine wave, you can click on the Simulink tab. And since sine wave is a source, so it will be under the source tab. You can click on the source. After you click on this, you can scroll this. Now, this will be initially visible to you. What you can do, you can click on this. So sine wave here, the sine wave is here. Sine wave block is here. What you can do, you can right click on this block. After you right click on this, information appears. What you can do, you can click on add block to the model untitled. After you do this, a model will be added to the untitled model that you have opened in the Simulink. Now to see that, let me switch back to the MATLAB. This untitled model, you can see a block is added to this untitled model that is named as sine wave. That is named as sine wave. Now to display this sine wave, what we can do, we can go back to the library. After I go back to the library, I can click on the sync. There is one tab that syncs. Now you can see there are different blocks available in this syncs. Now to display this sine waves, sine is a time varying waveform, you can click on the scope and right click on this and click add block to the model untitled. After you do that, let me switch back to this untitled model. You can see block is added that is referred as scope. Now to connect these, what you can do, click on this arrow and hit here. Now these two blocks are connected together. Now to see the result, I mean, is to see the sine wave actually. To see the sine wave, I click on this play button, and if I click on this, this will be executed. Whatever you have built here, whatever model you have built, that is executed, means that model is run. by this MATLAB, and depending upon for how much time you want to visualize this, means you want to perform the simulation actually, for how much time actually you want to simulation, that is specified here. Here is the simulation time is this time set to 10. You can change it. You can change it to 100, 1000, that's your choice, or 0.1, it's your choice for how much time you want to do the simulation. All right, now to see the result, actually, I double click on this this scope block. Now, after you do this, double click on this, another window pops up that looks like this. Since we are doing everything on Zoom, so I have to, I have to change the screen again and again. Please bear with me. Now you can see a sine wave is displayed here. A sine wave is displayed here. You can check, this looks like a sine wave with some frequency and the amplitude varies from -1 to 1. All right, now let me go back to the this untitled model that we have built in this. Why I'm saying this is untitled? Because the name is untitled here. Now you can save it. For example, I want to save it. Let me save it. You can say my sine wave, my sine wave. You can name it as my sine wave. Okay, so the name is my sine wave. All right. Now you can change the characteristics of the sine wave. Means you can change the amplitude, you can change the this phase, you can change the frequency. Let me show you that. Double click on the sine wave block, a window pops up that looks like something like this. That looks like this. You can see now you can change the amplitude here. For example, we want to set the amplitude to 2. We want to change the frequency to 2. Let me change the frequency to 2, or you can say 5 radians per second. You can also change the phase here. You can change the sample time here. I will tell you later on what do you mean by sample time. All right, so you can hit apply. Okay, now to see the result, let me go back to the model that we have built. That's the model that we have built. Now to display the result, I have to execute this, hit the display button, and you can see the result. Let me show you the result. You'll see this waveform appears. Now this looks a weird sine wave. What happened to this sine wave? Actually, this is the sine wave. Nothing happened to that sine. Now the problem with this, you don't have enough sample points. Means you don't have enough points available to you in which the MATLAB connects or plots it. For example, to illustrate this further, let me make this window slightly bigger. You can see there's a straight line between these 2 points. Actually, there is 1 point available to MATLAB here, 1 point available to. Now, what actually MATLAB tries to do, it always connects the these plots with a straight line. Now, what we should do to make this plot look like a sine, I should have more number of points. So, right, I should have more number of points. Now, to do that, let me switch back to this model to get more number of points. Now to have more sample points or simply more number of points, in short, click on this. So in the setting button that looks, this is called the configuration button. You can click on the configuration button, another window pops up that looks like this. That looks like that. Now you can see there is solver selection here. There are 2 solvers available. One is fixed, another is variable step. Now, and the solvers are available like these are the different solvers available to you. Now, what you can do here to solve this problem, you can set the maximum step size. Means between the 2 points, what's the maximum step size? Let me choose it to be 0.001. Let's see whether this solves the problem or not. Now, let me switch back to the model and run it again. Hit this play button. Now you can see the result looks like that. Double click on the scope and to see the result. See, I have to switch back the screen again and you can see this is the result that the plot looks like now. Now this is a clear sine wave, right? That has a frequency of 5 radians per second and has an amplitude of -2 to 2. All right, now what else we can do with the sine wave? Let me switch back to the model. Now let me bring one more sine wave here. Let me bring one more sine wave on this. Now for this, what I have to do, I have to click on this library browser. Let me show you that. This is the library browser. Now to bring one more sine wave source, so I have to click on the sources, then scroll down and click on the sine wave block. Right click on it, add block to the model sine wave, because the name of this model is now my sine wave. So you can click, you can now to see whether we have added one more sine wave to this. You can see now one more sine wave block appears here, and that's named as sine wave 1. All right, now I want to see the results on this this scope, on the same scope itself. Now what you can do, you can change the number of inputs to this scope. Either you right click on it. So when you right click on it, this appears there. There is one tab that is signals and ports. Click on signals and ports. That has number of input tabs in it, means number of input ports. And currently it is set to 1. Now you can change it to 2. Now you can see there are 2 inputs. Yeah, so now you can connect it to this. Now instead of displaying a sine wave, what we can do, we can display a cosine wave. So double click on the sine wave block 1 and change the phase to pi by 2. So we know as sine wave and cosine wave, the only difference is the phase pi by 2. So you can click pi by 2, you can see the result. And let me change the amplitude first back to 1 and 1. So you can see. Now run this. Now you can see the result. Let me show you the result. The result looks like this. The result looks like this. So this is our sine wave and cosine wave. You can see one is cosine, another is sine. Now you can name these plots also. Now let me show you that. Now let me show you how to do that, how to name these plots. Now since this is sine wave, this is cosine wave, you know that. So let me, to display the name, you can click on this wire. You can say this is sine wave. Now to name this, you can click on this wire and you can type cosine wave. So this is cosine wave. Now to see the result, let me run it. Double click on scope. Now to see the result, what I have done, this is the sine wave. Now this is not displayed there. Now to see display this, click on this configuration properties tab. Now when you click on this, a window pop-up, small window pops up that looks like this. I already told you we have to share the screen again and again. Now what you can do, you can click on this display and say show legend. So when you apply this, legend appears here, and to display, to show you the result, let me switch back to the scope window. This is the scope window, you can see, and the yellow one is sine wave and the blue one is cosine. So you can display this. This is how you display. You can see hundreds of this waves simultaneously on this scope window. So you can have hundreds of inputs. This scope window. Now let me close this and let me go back and show you one more way to display this sine wave. So one more way to display this sine wave is just click image. If you want to see separately these, if you want to see now sine and this on two different windows on the same scope, what for that, what you can do, let me show you the what I have done. I have clicked on the configuration tab on the scope, and this appears. You can see now. Sorry, I don't have to click on this. I have to click on this scope window. Now there is this view button. Now click on the layout. When you click on the layout, you can see that this thing appears here. You can see layout should look like this. Now I hope this is visible to you. One is the cosine wave, another is the sine. You can see now one is the sine wave, another is the cosine wave. So this is how you display these waveform. Now let me bring a few more blocks from that library browser on this. Now let me switch back to the library browser. Simply library. There are different sources available to you. You can see there is step wave, there is waveform generator, there is uniform random number generator, there is repeating sequence, there is ramp, there is one constant block. So let me show you how to do addition of two constant values. So let me add it on the same model. Instead of making a different model, let me add it to the same. So you can make a different model, by the way. You can make a different model here. So let me switch back to model. You can see one block is added to this, that is named as constant. Now let me add one more constant. So let me switch back to this library window and click on this constant, add block to the model sine wave. You can see one more constant appears. Let me name this one as, you can name these, by the way. You can click on this constant one and grab it. You can say this is A, and you can say Sorry, let me show you what I'm doing actually currently here. I am changing the name of this constant. So I change the name of this. How to do that? Let me show you on this. Click on this constant one and you can rub that name and type a different name. So this is B. Now I want to add it. I want to add these constants. Suppose A is equal to 5. Now how to change the value here? When you double click on the block, after you double click on this block, a window pops up that looks like this. A window pops up that. Now to change the value, let me write 5. So you can say apply, and to see the result, let me show you either the value changer. You can see the value of A change to 5, and you can see the value of B is still 1. Let me also change the value of B to suppose 3. So this is 3. So apply, you can see the value change. After you click on this block, window appears, you can change the value. And now I want to add these values. So to add these values, there is one sum block in this library browser. So to sum any two values in this, you can see, go back to commonly used blocks. You can see there is one sum block here. You can see, and right click on this and click on add. Means right click on add this to Sine. So you can see now you can connect these two. So this will add these two. Now to display the result, means to see the result, I can either view it on the scope also, but this is better to view the time varying waveform. I can just display the result on. Sorry, I haven't shown you what I have done. Let me share the screen. Since I forgot this because I have to share the screen also with you. Have a look at this. I have added this block. This is the block that got added. This is the sum block that now I want to add this A and B. Now to do that, let me show you again. This is the block that got added here, and I want to connect this to here and this to here. Now I want to display the result. Means what is the sum of A and B here? A is 5, B is 3. To do that, I can do this on the scope block itself. By the way, there is no need to change the scope. Means you can add a scope here, but in one more block available in sync is this display. You can see there is one block that's display that will give you the value, that's the output of this sum. Now let me add it. So I click on add block to my model Sine. Let me show you that the block got added to this our model, and you can click on this and connect this to this. Now to see the result, means to see the result of A plus B, I have to first run it. Means click on this play button, and you can see the result is 8. 5 plus 3 is 8. So you can see the result. So 5 plus 3 is 8. So this adds these two. Now I can also subtract these two values. Now to do the subtraction, just click on the sum block. Click on the sum block, a window pops up that looks something like this. There is plus plus here. Now you can say plus minus. So this is, after do that, you apply it, and let me show you what. So this is the. So now you are subtracting B from A. You can check now to see the result. Again, you have to just run this model. You have to run this, means click on this play button. You can see the result is 2. 5 minus 3 is 2. You can see this is correct. So this is how we add blocks. In short, the aim is to see how to add how to add blocks to any model. Means the model that you want to build, how do you add these blocks on this Simulink. All right, so let me show you how to do the product of these two. Let me show to do the product. Let me go back to the Simulink library. You can see, and I click on this commonly used blocks. You can see there is one block named as product, and to add it to our model, you can right click on it, and there this appears. That's add block to model my sine wave. After you do that, you can see model is a block is added that's named as product. Now let me delete this sum block, and let me keep it there, and also do the product of these two. So to do the product, I can click on this. So this is, now I will also do the sum and addition. Now what you can do to add one more display here, you can go back to the library. You can go back, but you don't need to do, if you want to add the same block that's already available in your in this model that you have built, you can just copy it here. What you can do, you can click on the control and hit the mouse button and drag the mouse button. So you can see now display got dragged there, means you have now one more display available there, and you can connect these two. Now to see the result, means to see the result of this product and this subtraction, just hit the run button. You will see the result is 5 3 is 15, so 5 minus 3 is 2. You can see this is how we add the models, or how do you add blocks on this Simulink to any model. All right, now let me show you a few more sources that are available, minus step signal, or you can say ramp signal, that are available to us in this Simulink. So let me go back to the library. To go back to the library, let me switch the screen. So this is our screen. So let me go click on the source tab, and you can see there are different kind of sources that are available to you. Play with these, please play with these. Now let me first add as ramp source. So this is the ramp source. So I will right click on it, add this. And similarly, I want to add one step wave. So I will also add this. So right click on this, add this. Then similarly, I want to see the pulse generator. So right click on it, add block to the my model sine wave. You will see these models will be added to our model that we have built. You can see the different blocks are added here, although that got jumbled. The blocks got jumbled here. Let me show you how these plots look. So this is our step, this is the ramp, and this is the pulse generator. I want to display these waveforms also. Now first let me change the characteristics of this pulse generator. The rest I will keep as is. This is the ramp, it will start from 0 and start increasing. This is the step, it will start at some point, means it will give me a step at some instant of time, and it will be equal to 1, means it will change from 0 to 1. Now I want to change the characteristics of this pulse generator. Okay, let me show you that. So double click on this pulse generator. Let me show you. A window will pop up. A window pops up that looks like this. You can see that looks like this. And to change the amplitude of this pulse wave will be 1. The period is 10. Let me change the period equal to 2. And let's keep it to 5. Means 5% of this period will be, it will be on for 5% of this period. So this is a pulse generator. After I click this, okay, and all right, so let me share the screen with you. So this is our model. I want to display these simultaneously. What I can do, I can add a scope block to this, because these are time varying waveforms. So I can add a scope block this, and I can simply drag this. So if I drag this, but you have to click, keep pressing on enter. You can see there are 2 inputs. Now I want 3 inputs. So you can double click it. You can double click on it. A window appears that looks like this. Now we have only 2 windows here, but I want 3 windows, means I want to display simultaneously. Click on this configuration button, click on this button here. If you click on this, a window pops up that looks like this. That is this, and you can see the number of input ports is 2. Now you can change it 3. So you can see this is, now we have 3. And this, all right, let me share the screen with you. Let me go back to the model. So this is the model. Now you can see there are 3 inputs. Let me make it slightly bigger. There are 3 inputs here. See, if I want to see the sine wave also, so I can change the number of inputs to 4. So let me do that also. Let me change the number of inputs to 4. So what you have to do, you have to double click this scope. A window pops up. A window pops up. Now you can see the window looks like this. And after this, what you can do, you can click on this configuration button. And after you click on the configuration, another window pops up. That looks like this. Now you have set this number of inputs 3. I want to set it to 4 or 5, whatever is the requirement. So now there are 4 windows. Now let me show you that there will be 4 inputs to this scope window. You can see there are 4. I want to see the sine wave. So the first input is sine wave. Second input is this pulse generator. Third is step for this ramp. Now I want to name these. To name these, click on the wire itself, means click on this connection. After you double click on it, now the name is sine wave. It's already typed here. We already typed it. Now this is pulse. I want to call it pulse. So this is the pulse wave. And now I want to see this one. This is a step wave or a step signal. And I want to call it ramp signal. Now to display the result, let me run it. And after this, double click on the scope 1. After you double click on this, a window will pop up and that looks like this. A window will pop up that looks like this. So a window pops up that looks like. Let me share the screen with you. Please bear with me, even though I have to change the screen again and again. You can see this is our sine wave with some frequency and amplitude. Amplitude varies from -1 to 1. This is our pulse generator. It has some period. It repeats after some time, minus 2. As we set the period equal to 2, and it's on for only 5% of the time. You can say, because I have set it on, means the pulse is on for 5% of the time. That's what I set it. You can change it to any value. You can see this is the step wave, and the step becomes 1 at t equal to 1. You can see it becomes equal to 1t. Now this is the ramp signal. This is continuously increasing. So these are different waveforms that are available to you in this Simulink and this browser. All right. I hope this is visible to you. I hope this is how you are seeing this right now. So this is how we can add different blocks. Now this is just a simple introduction. Now this is so much powerful. This toolbox is so, you can do any analysis in this that you have seen, any communication, be it signal processing. You can build any system in it, almost any system in this Simulink that you have studied. You can build any system that you have studied. But if you in future, if you want to build any system, you can do that in Simulink also. My point is that you can build any, you can do the analysis. This is just a simple introduction. Now in the next session, we'll see how to do integration and differentiation in Matlab. Let's do that in the next session. Let me end it here. I hope you understood. Please practice it. Please practice it. Now you may not get it one because I have to switch back to the Windows one again and again. You may not have got all the concepts in one go. Please do the practice, and if you didn't get the idea, contact me. All right, let me end it here.